So our next speaker is Ulrich Loup. Oh, sorry, thank you. While he's setting up, he's going to speak about the Helmholtz Earth and Environmental Data Hub, highly distributed data that thrives on metadata. And Ulrich worked or studied computer science, and he did his doctoral thesis on the combination of practical solution techniques and mathematical theories to efficiently compute exact solutions to nonlinear constraint systems. He's worked as an IT consultant in the energy sector, and his focus is currently on highly available web services for big geodata at the German Weather Agency. And he's involved in the challenging task of research data management in the field of earth and environmental sciences at the Forschungszentrum Ulrich. Welcome and thank you.
Thank you. I'm delighted to be here. Thank you. Environmental Earth and Environmental Data Hub. This is what I'm going to talk about. By the way, somehow this screen is not fitting. Okay, so the slides, I also posted that link in the chat if you want to get it. The QR code is not complete here. Okay, so when you hear Earth and Environmental Data Hub, what is the first thing that pops into your mind? Maybe you can give me quick feedback. Satellite data. What do you think of Data Hub? What is it? Repository? Mm-hmm. Some page where I can go and get the data. Mm-hmm. Okay. I'm happy that the word cloud space didn't come up. So the data is somehow there. Yeah, so what is this Helmholtz Data Hub for the research field Earth and Environment? It is actually an initiative, first of all. So this is what I got from the official pages. It's an initiative to implement FAIR principles for all the data in this research field on Helmholtz. Yeah, there are some details, so we want to provide tool support and so on. What it actually is like a funding initiative. So this is like the organizational overview. There are involved 7 research centers, which are all under this umbrella of the research field. They are kind of enabled with other projects, which are Tirino, Moses, somehow, which are already existing. And this Data Hub initiative then links also to other, maybe even wider initiatives like the NFDI, European level, ERC, and so on. So it's an initiative, and yeah. How this is gonna work. So same as my predecessor, so Mario, right? It's kind of an approach which is more top-down. We look into the problem and want to solve it somehow. These are the locations of the 7 research centers. So we look at very distributed data in a geo context, and we are also looking at very heterogeneous data. I made like this picture where you can see we have like stationary installations, like these weather stations, lysimeters, which measure somehow the ground soil. And there's also going on some sampling, people collect things, mobile sensors like ships, aircraft, trains, all of those like measure data with sensors or manually. There are remote measurements like satellites or radars. So it's a lot of data and it is produced already for it's not right on the screen, decades. And per center, you could say it's thousands of measurement devices which produce those data. maybe at a very high rate, like per minute, per every 5 seconds. And this is the main focus of the project now. We focus on the geolocated time series data. Okay. Now, what are the jobs? So maybe a bit different to this data mesh approach. We didn't have that book. And there was no one saying we should do it exactly like this. So we talked. I wasn't there in the initial phase, but there were a lot of talks going on, like 2 years of talking. How should we do this? We have the initiative, we had positions in each centers who really follow this initiative. One of those were on my first slide. This is like the core team, we work together. And well, we figured out for us, it's more or less condensed into 2 jobs. First is design the infrastructure. Second is design the metadata schema. So that when you have the infrastructure, you can really read the data. It's not just something. Okay, so this is like the structure of my talk too. We'll focus on those 2 jobs. So for the infrastructure design, the most important thing is to establish a or several common data interfaces, these APIs. And then, of course, systems should be implemented to feed into these interfaces, and then other systems which add the metadata, like you saw in the first talk. This is the same approach, actually. And yeah, there should be tools to somehow in the ecosystem provide something like data quality control. Yeah. And then, of course, the next step is to integrate existing things, which are there, into this new approach. Somehow do migration or, yeah. Workflows have to be adapted and then get the people to use it. So for the other job, we have to implement a or several common metadata schemas. 7 centers, 7 traditions. This is easily said, but air temperature could be spelled in very, very different ways. Like you have 12 air temperatures out there, but you don't know for all of them that they are really air temperature. A system doesn't know that. A portal, which is somehow plugged in, doesn't know that. So you will find a list of text only. So we have to put semantics inside. Persistent identifiers are important to, yeah, like implement this F of fair to find actually things. Then to further improve quality of what is inside your metadata schema, you need something which is, yeah, a vocabulary. We established vocabularies for the measurement devices, metadata, so which is in there are device types, manufacturers. You don't, yeah, here you see. And also for the measurement metadata, so the properties which are measured, like I said, this air temperature. And we need to organize workflows for the curation of the things. They don't work by themselves. So that are the jobs. I will start with the infrastructure. That is what we actually did. This is running. I hope to see, yeah, so here you see also the right side there is the end user, and at the left side there is the data provider. So this is the data flow is from there to there, from left to right. The data provider has actually in this approach 2 jobs. Provide the data and configure the time series management system to get the data. So how is this data file structured? Where is it using commas or semicolons or something? This is just configured in this system. And then the data provider goes to the sensor management system and says, what is the data about? So the metadata is entered there. Then there is a synchronizer, and the synchronizer feeds, so the synchronizer connects the data with the metadata and feeds this into the common data interface, which we, for this time series data, use the Sender Things API. This is an OGC standard. And it provides not only the API, like the URLs you can use. Below you have a data model for metadata and data. So you can pretty nicely combine those things. Then you could set up post-processing workflows like the quality control based on the API and this data model. And then connect whatever you need, like repositories, some client applications like the Python scripts the researchers use, monitoring application, that is the first thing you need when the data provider wants to see if the data really gets there, like Grafana dashboards, and a portal. The portal is this, like, hey, we have the environment DataHub. Go to this web page, single entry point. Then you see everything. Okay, this is just a list or some impressions, some screenshots from what we have. This is one of the sensor management systems. We actually have two. So the ocean people, which were, you saw these dots on the coastal line, they use a different approach, O2A registry. So here this is the system where you enter the metadata. And you see already when you here, for example, enter a device measuring air temperature, you have a list of already suggestions which come from this controlled vocabulary. If your measured quantity or whatever is not in there, you press the plus button, and this automatically gives an issue at the curation board. So it is extensible too. This is an impression of like this configuration interface, also a self-service, where you enter things like how is my file parsed, more technical level. This is an impression of what the other user, the end user, would use, this single entry point portal. This is the Earth data portal, which has a data part and a viewer part. The data part is more or less a repository, a metadata repository, also harvesting DOIs, papers, and then from those interface we have. And the viewers are something more. This is like a WebGIS, where you can fully configure what you want to see. And yeah, this is maybe capable of adding any OGC API service you want to integrate, and also this STA, this Sensor Things API points. So yeah, and as I said, it is customizable. So you are able to maybe domain specifically create a viewer for just your working group, add your data endpoints, and then they can see only their data. But you could also go to the catalog and see the other viewers and traverse through this data. So that's what's there already. This is a quick view of this repository for the metadata on the portal. So the outlook, this is not what we actually want to finish with. We want to add another layer into this infrastructure, which I call now the interoperability layer. This highlights this I in FAIR. Because connecting those STA directly to the clients is a bit tedious. It is, especially for those client applications, difficult because people don't want to learn STA, this interface. They want to use just. So we want to implement, or already started to implement, like middleware, intermediate services, a download service, which you can easily ask, give me the package for this thing, my rover which collects data the whole year. Then the download service looks into the interface, packages the data, puts it into an arrow-array structure, zips it, and moves it to an S3 storage, S3 storage or something, or even to a repository. A quality control service which helps to visualize data for the first, but then also mark data, which is good for workflows which are also manually checking the quality. A catalog service which just gets the metadata out of the interface and then publishes it in a unified API way to repositories and other applications, which then just query the API, not have to understand this here. So that's for the infrastructure. Now the metadata part, I brought the data model. This is the standard things data model. To structure a bit more, these entities are just for metadata, and this is the data part. And the all connecting entity is a data stream. A data stream is just a wrapper around a list of observations. And connected to a data stream is a sensor, a thing. A thing is like the platform the sensor is installed on, locations, and you can describe everything you need. Now, what we had to do, the fields here are not sufficient. They are generic. So what we need is a field for model, manufacturer, serial number in the sensor. We need a field for, here in the thing, responsible persons, very important. So we added a schema for that. We call that the template schema because the project is called template, which produced it. And as soon as this was established, the whole infrastructure made sense. Before, it just was there. Research centers put their data on this SDA interface, but the portal couldn't really understand. So it is just, you could see the time series, but the thing has a name. Okay, do you want to encode everything into the description? No, we want to work with it. And this is also the key to do it interoperable. Okay. Just a quick outlook. We have to extend the schema further. Surprise. Quality information is added because we want to add this quality service in the middle. And for the controlled vocabularies, maybe you have somehow got this between the lines. This curation team, it's a bit small. People need to be motivated to do the curation, to use these systems, and Then we want to structure even more. That means we want to introduce more these interconnecting things like the ontologies, so that also LLMs could understand our vocabularies, and we could lower the barriers for the researchers who use this. They just use the LLM and then they can work with the system. I summed up some of our current challenges here, but they are maybe a good starting point for the next unconference session tomorrow. So for these interoperability things, we need a few things, a few answers, and we need some, good services who help us to manage these RDFs, these ontologies. And we need something like a methods database. So optimally something which is a function as a service. So you could query the URL, say I want to execute this function min-max with these parameters, and then and with this input data, and then the result comes back in a JSON or something. So this would be optimally to enhance this kind of. Okay, so yeah, I will close with those question marks.